Steady state means, that this is going on for a long time. It's not like a switching, so it goes forever, right? So that's what you're going to deal with here, okay? Right? Well, what did we say? If the voltage and currents are changing as a function of time, what else you need? What components, passive components, you need to include in your circuit? What did we learn so far? If the voltages and currents are changing as a function of time, which means that they are AC circuits, what components need to be included in the circuit?
Inductor, capacitor,
and resistor. Right, remember what we said? That's why we didn't see inductors and capacitors when we were doing chapter 1, 2, 3, and 4, because everything was DC, digital, simple shit. But when you have these changing signals, now you have a voltage and, you're going to have charging and discharging capacitors of inductors, and you have to include them every time, which complicates your analysis a lot. And you'll see quickly what it really means. Luckily, there's a mathematical conversion that some smart engineers figured out. And what you basically do when you have an AC circuit with all the voltage current sources that are AC, with resistors, inductors, and capacitors, if you try to do it in time domain, you would get if you have a inductor capacitor, only one inductor capacitor resistor, you will have a second order differential equation. Imagine if you have more than one. You will have third, fourth, fifth order differential equations really quickly. And you can't solve it like that. But what you can do, you can use Laplace and convert basically your time domain circuit into frequency domain, and then everything is like chapter 4. Okay? That's pretty much it. So you'll get a time domain circuit with an AC voltages, AC currents, inductor, capacitor, resistors. First thing you're going to do is going to convert everything in frequency domain. Voltage and current become phasors, and we'll talk about that now, how you convert this into phasor, which is a frequency domain representation of this. Resistors are still resistors, they're stupid. And then inductors and capacitors become also impedances in ohms. So resistors are in ohms, but also inductors and capacitors in frequency become impedances, which are in ohms. So now you're basically talking about voltage, current, and resistor, inductor, capacitor impedances in ohms, which means chapter 1, 2, 3, 4 work. Okay, that's it. But the only difference here is that inductor impedance is j omega L, so you have that complex number j in front. So this omega is very important. Tells you what the frequency matters in a specified frequency domain of the circuit. By the way, omega is, if you don't know that, omega is 2 pi f, or 2 pi over period t, right? That's simple stuff, right? So that's the connection. Okay? It's given in radians per second usually, okay? Angular frequency of your circuit. Then capacitors become a minus j over omega c. And the resistors and capacitors, depending if you have a phase shift or not, they will be also complex numbers. That's the only difference between chapter 4 and chapters 1, 2, 3, and 4 and chapter 9, because your analysis is still Ohm's law, KVL, Kirchhoff laws, current dividers. You can do mesh current, node voltage, Thevenin, Norton, source summation, everything you can do, like you did in chapter 4, but your circuit will be a complex number of values, right? So you have to use Wolfram alpha. It's even more important to use Wolfram alpha this time around. Just plug it in. You don't have to work with the complex numbers. Wolfram alpha, I'll show you one or two today and on Wednesday how you use Wolfram alpha. It's easy. Yes. So you take advantage of it, that I'm giving you that chance. Okay? You don't have to do it by hand. And that's pretty much it. That's what we're going to do in chapter 9. And then next week I'll show you a little bit of transformers. You'll have a homework to play with it. And by the end of next week, you will be pretty much, that's chapter exam number 2. which is, when's the exam number 2?
So Wednesday, or it's a Monday.
What day?
Or it's a, Wednesday. It's 2 weeks from this Wednesday.
Okay.
12 or 13.
So you'll be ready next week, you know, for it, hopefully.
Hopefully.
Hopefully you study, you know, you need to study by now. Or, you know, take next week off, something, right? However time you need, I don't know, but you know how comfortable you are. Okay, that's what's coming up. And then you'll do, chapter 10 is AC power AC circuits a little bit. That's not gonna bug you a lot, that can be complicated. You'll know basics for the power class that you will take later on if you're a double E. Mechanical engineers, you're done after this, and I know you're all happy about it.
It used to be
Easy
2 classes,
class.
you used to take 2 classes.
You still have to take